Let's go to inverse of matrices. Let A inverse like this. Let this be the inverse of matrix A. A inverse, the inverse of matrix A is equal to its adjoint divided by its determinant. So we can write this like this, or write A inverse is equal to 1 over determinant times adjoint. This means the same thing. This means the same thing. So let's take a few examples. Here are some matrices whose inverses we are to find. Let's start from question 1, which is A. I'll just do one 2 by 2 matrix and one 3 by 3 matrix. One inverse each. You do the rest yourself. So let's go. Let's find the inverse of the matrix A, which contains the elements 2, 3, 4, 5. Let's find the inverse of matrix A, which contains the elements 2, 3, 4, 5. This is very, very simple to do. We have said that the inverse of a matrix is its determinant times its 1 over determinant times its adjoint, or adjoint over determinant. So let's find the determinant first. The determinant will be 2 times 5 minus 4 times 3. I'm sure you are familiar with this. So 10 minus 12. The determinant of A is what? Minus 2. Let's now find the adjoint. To find the adjoint of A, we just use the shortcut method that we learned. The adjoint of A will be 5, 2. You swap the elements in the main diagonal. From 2, 5, it will become 5, 2. From 2, 5 here, it becomes 5, 2. Then multiply this by minus 1 each. So these elements in the second diagonal become minus 3, minus 4. So this is the adjoint of A. That means, therefore, that the inverse of A, which is what? Adjoint of A over determinant of A, is equal to 5 minus 3 minus 4, 2 divided by minus 2. So I can write that like that. I'll write minus 1. I'll write 1 over minus 2. So I'm writing 1 over determinant. 1 over minus 2 times 5 minus 3 minus 4, 2. So this gives me A inverse is equal to minus 1 over 2 times 5. That's minus 5 over 2. Minus 1 over 2 times 3. 3 over 2. Minus 1 over 2 times minus 4. I'm multiplying minus 1 over 2 by each term in each element in the matrix. Minus 1 over 2 times minus 4. What does that give me? 2. Then minus 1 over 2 times 2 gives me minus 1. So this is the inverse of the matrix A. You answer the remaining 3 like that. So let me just write here. Classwork. Numbers 2, 3, and 4. Find the determinant of these 2 by 2 matrices yourself. Let's go to number 5. I think the first question, yeah. Okay, let's go to number 5. C is 1, 4, 3, 2, 5 minus 1, 3, 6 minus 2. Let's find the determinant of this 3 by 3 matrix. Sorry, its inverse. C is equal to 1, 4, 2, 2, 5 minus 1, 1, 4, 2, 1, 4, 3, 2, 5 minus 1, 3, 6 minus 2. This one is 1, 4, 3. So let's find the inverse of this matrix. To find its inverse, we first need to find the determinant. Let's find the determinant. That will be what? You remember how we do determinants? Plus, minus, plus, minus, plus, minus, plus, minus, plus. So, first, this will be plus 1 times, when I cross 1, I have 5 minus 1, 6. And what? Minus 2 left. So that's minus 1 times minus 10 minus minus 6. From the first row, I'm using the first row. Next will be what? Minus 4. 4 should take a minus sign. When I cross minus 4, what do I have? When I cross 4, I mean, when I cross the row and column of 4, I'll have 2, minus 2, 3, minus 1 left. That's minus 4 minus minus 3. So minus 4, minus 4, minus minus 3. Thirdly, I'll now cross the row and column of what? 3. 3 should take a plus sign. So that's plus 3. This is 12 minus 15. So that gives us what? That's plus 3. 12 minus 15. So this is what? Let me put it together here. That's plus 1 times minus 10 plus 6 is minus 4. This is what? Minus 4. Minus 4 times minus 4 plus 3, that's minus 1. Then this is what? Plus 3 times 12 minus 15, minus 3. So my answer is minus 4. I'm writing from here. Minus 4 plus 4 minus 9. Take note. Minus 4 plus 4 minus 9. That gives me what? Minus 9. So my determinant is minus 9. Now, let me find the adjoint. I have the determinant of C now. I'll go ahead and find the adjoint of C. To get the adjoint of C, first, I need to find the matrix of cofactors of C. So I would say I need to find the matrix of cofactors of C. So I'll say let M equals matrix of cofactors of C. Let M equals matrix of cofactors of C. So let's go to the next page. M will be, what is the cofactor of the first element? 1. 1 should take a what? Positive sign. Its cofactor will be minus 10 minus minus 6. That's minus 10 plus 6 minus 4. Minus 4 times plus will give you minus 4. So the cofactor of 1 is what? Minus 4. Let's go ahead and find the cofactor of 4. I found the cofactor of 1. And I want to find the cofactor of 4. How do I do that? 4 should take a negative sign. So I'll keep my minus in mind. Cross the row and column of 4. What do you have? You have minus 2 times 2. That's minus 4. Then minus 3. Minus 1 times 3. That's what? Minus 3. So that's minus. That's what? Minus times minus 4 minus 3. For the cofactor of 4, I'll get minus times minus 4 minus 3. That's minus times minus 4 plus 3. That's what? That's what? Minus times minus 1. So that's 1. The cofactor of 4 is 1. So I write 1 here. Let me go ahead and find the cofactor of 3. To get the cofactor of 3, first I know it should take a plus sign. After crossing the row and column of 3, what I have left is 12 minus 15. 12 minus 15 is minus 3. Minus 3 times plus sign will give me what? Minus 3 times plus sign gives me minus 3. So the cofactor for this position is minus 3. Let's go on. Let me find the cofactor of 2. This is 2 here. To find the cofactor of 2, I'll cross out its column and row. What I have left, 2 should take a negative sign, don't forget. After crossing out its column and row, what I have left is minus 8 from 4 times minus 2, minus 8. Then 3 times 6, 18. Minus 8 minus 18, that's minus 26. Minus 26 times this minus sign will give me plus 26. So the cofactor of 2 is what? 26. Take note. Let's go ahead. Also, find the cofactor of 5. 5 is right in the middle here. And its cofactor should take a plus sign. So after crossing the column and row of 5, what do I have left? 1 times minus 2, minus 2, 3 times 3, 9. So that gives me what? Minus 2 minus 9. That's minus 11 times the plus sign here. Plus times minus 11 will give you what? Minus 11. So the cofactor of 5 is minus 11. Then next, we find the cofactor of minus 1. To find the cofactor of minus 1, all I need to do is note that its sign should be negative. So I'll cross out the column and row where minus 1 is located. I have 1 times 6 left. 1 times 6, 6. 4 times 3, 12. 6 minus 12. That's minus 6. Minus 6 times minus sign that the cofactor should be given. That gives me plus 6. So the cofactor of minus 1 is plus 6. Let's now go ahead, find the cofactor of 3. How do I get the cofactor of 3? Cross out the column and row where 3 belongs. Its cofactor should have a positive sign. And that should be what? After crossing out its row and column, I have 4 times minus 1 left, minus 4. Then 5 times 3 is 15. That's minus 4 times 15. Sorry, minus 4 minus 15. Minus 4 minus 15 is what? Minus 19. But that cofactor should be given a plus sign. So plus times minus 19 gives me minus 19. The cofactor of 3 here is minus 19. On and on. Let's find the cofactor of 6. In this position, 6 is in the third row, second column. Its cofactor should take a negative sign. After crossing out those things that I've just crossed out, I have 1 times minus 1 left, minus 1. Then 2 times 3 is 6. Minus 1 minus 6. What does that give you? Minus 1 minus 6. That's minus 7. The cofactor of 6 should take a what? Should take a negative sign. So minus 7 times minus 1 gives you what? Plus 7. So the cofactor of 6 is what? Plus 7. Lastly, I'll find the cofactor of the element here. The last element here is minus 2. What's the cofactor of minus 2? All I need to cross out the row and column of minus 2. Its cofactor should take a plus sign. Its cofactor should take a positive sign. So after crossing its column and row, I have what? 1 times 5, 5. Minus 2 times 4, 8. 5 minus 8 is minus 3. Minus 3 times plus sign is still minus 3. So the cofactor of minus 2 is what? Minus 3. Never get tired when doing this. So the adjoint, I've gotten the matrix of cofactors of C. I'll now write that the adjoint of C is the transpose of its matrix of cofactors. That means the adjoint of C is what? Minus 4 1 minus 3, 26 minus 11, 6, then minus 1, 7, minus 3. This is the adjoint of C. This is the adjoint of C. So now I can find the inverse of C. The inverse of C should be the adjoint of C over the determinant of C. Sorry, I'm writing A inverse. The inverse of C should be the determinant of C, should be the adjoint of C, should be the adjoint of C divided by the determinant of C, or 1 over determinant of C times adjoint of C. So all I need to do here now is put the two together. What's my determinant? I'll write it down. 1 over, then multiply it by my adjoint. My adjoint is minus 4, 26 minus 1, 1 minus 11, 7, minus 3, 6, minus 3. This is the adjoint of C. Okay, let me go up a bit more to pick up its determinant. The determinant of C is what? Minus 9. So I'll just do this. So finally, that gives me what? That gives me minus 1 over 9. Okay, I just need to multiply each element by minus 1 over 9. So minus 1 over 9 times minus 4 gives me 4 over 9. This one gives me minus 26 over 9. This will give me 1 over 9. Next here too, this will give me minus 1 over 9. This will give 11 over 9. This will give what? Minus 1 over 9 times 7. That's minus 7. That's minus 7 over 9. On the third row, minus 1 over 9 times minus 3 will give me what? 1 over 3. Minus 1 over 9 times 6 will give me minus 2 over 3. Minus 1 over 9 times minus 3 again gives what? Plus 1 over 3. So this is the inverse of C. And that's how to find the inverse of a 3 by 3 matrix. I gave 3 examples, but I have only done number 5. So you do number 6 and 7 as your exercise here too, and submit in the comment section. So exercise 6 and 7. So you have 2 exercises in this video now. 6 and 7 for 3 by 3 matrices, then 2, 3, and 4 for the inverse of 2 by 2 matrices. Good luck.